Hi, welcome to another lesson at Edu Solutions Institute. Well, today we'll be looking at the CSEC syllabus, and we're continuing from last week's session where we looked at the reactivity series, which is one variable that we have to consider when we're looking at the reactions for single displacement. Now, before we look at writing chemical equations, we're going to actually look into the next part of things out to consider, which are the solubility rules in terms of what's the state of these compounds or chemicals that we're going to use in these specific reactions. Now, let's look at the solubility rule. Now, what is the solubility rule? It is based on, it tells you the state of matter that this chemical will be when it is inside of a reaction. Now, the word precipitate or the precipitation reaction takes place in double displacement that produces a precipitate. Now, what's a precipitate? It is a solid that is formed when two substances are mixed together. So if you mix two chemicals together and at the bottom of those, what is formed, we see some solid objects. Those solid objects, we call them as precipitates. Because they're solid, they're going to be in a solid state, right? Now, how do we know without carrying out individual experiments what substance is going to be liquid, what's going to be gas, what's going to be soluble, what's going to be insoluble? We look at what we call our solubility rules. So these rules are very important, and it's a must that we remember these rules. Now, the first rule says that any compound that is nitrate-based are soluble, right? So if it's sodium nitrate, aluminum nitrate, calcium nitrate, any nitrate solution is soluble. So once there's a chemical that you're going to mix that it is a nitrate, then the state for it would be a soluble state. And to represent soluble, then we use AQ, which means aqueous. And aqueous means it can mix with water and get dissolved in water. All right, then we look at all ammonium ions or lithium, sodium, potassium, rubidium, cesium, francium are compounds are soluble. And what this means is that these elements are in group 1 of the periodic table alongside with ammonium. These are all soluble. So it doesn't matter what you mix them with, if it is sodium chloride, sodium peroxide, potassium permanganate, whatever the compound is, once it has these specific metals in it, they're going to be soluble. We look at all carbonates, phosphates, and hydroxides are insoluble, except cations in rule 2. So if we're looking at potassium carbonate, because it's in group 2, it's in the rule 2, it is going to be soluble. But if we look at calcium carbonate, then it's going to be insoluble. All right, same thing applies to phosphates or hydroxides. And then we look at all chlorides, bromides, and iodides are soluble except these 3. So except it mixing with Ag silver, Pb lead, or Hg mercury, then all bromides, chlorides, or iodides are soluble. So if it's silver iodide, then it's going to be insoluble. If it's lead bromide, it's going to be insoluble. If it's mercury chloride, then it's also going to be insoluble. Then we look at all sulfates are soluble, except if it's mixed with calcium, strontium, barium, radium, and lead. So therefore, if it is sodium sulfate, it's going to be soluble. If it's aluminum sulfate, it's going to be soluble. It's only not soluble if it's mixed with these 5 different ions. Right? And if we look at, we focus here, says that strontium sulfate. So if we need to know if it is soluble, we look at the sulfates. It's all soluble except calcium, strontium, barium, radium, and lead. And because it's strontium sulfate, it's going to be insoluble. Sodium nitrate, first rule, all nitrates are soluble. So hence it will be soluble. Lead chloride, we look at rule 4. All chlorides are soluble except it is combined with silver, lead 2 plus, or Hg. Now this is a lead 2 plus ion. How do we know? Because the Pb gave the chlorine 2 and the chlorine gave Pb1. So therefore, because it's Pb, 1 Pb and 2 Cl, then we know it's Pb2 plus, hence it's going to be insoluble. Now, what's the purpose of the solubility rule? It's to put in our formulas, when we write our chemical formulas, the state that these substances are in. Now, if we're not going to look at predicting the products as yet, that's our next list. But as we can see that PbNO3, which is lead nitrate, it has an aqueous state. So notice there is a bracket with AQ at the bottom, and that represents the state that this substance is in. And we know it's aqueous because it's soluble, because we know all nitrates are soluble. And if we look at Ki, Ki is aqueous, right? And if we go back to the rules, it's an I is an iodide, and we see all of them are soluble except for Ag, Pb2, or Hg+. And we see here that this Ki, so it's also going to be aqueous. Now, if we look at the product form, PbI2. Now, PbI2 means that it is lead iodide. So if we look back on the iodide rule, Pb is an exception to the solubility. So therefore, this PbI2 will be insoluble, hence it will produce a precipitate, and hence the solution will be a solid state. And then the KNO3, again, it's a nitrate, so all nitrates are soluble. We get an aqueous for that state. All right. So those are the rules. So if we look here, let's do this one. Right? Sodium chloride is going to be aqueous. All nitrates soluble, so AgNO3 would be soluble, so that's aqueous. What is NaNO3? We know that NO3 is the nitrate part. We know that all nitrates are soluble, so it will be aqueous for NaNO3. And AgCl2, AgCl, we go back to our rule. Cls are soluble except it's Ag mix, Pb2 plus or Hg plus. And because this is an AgCl, then we know it's going to be a precipitate, which means it's going to produce a solid at the bottom, so its state will be solid. All right, so that's how you know if it's a solid or if it's aqueous. And then some equations we'll look at when it is a gas, right? So like oxygen gas, hydrogen gas, right? And those are normally diatomic. Diatomic means it's like O2. We have two O's that have two of the same element bonding to give you a molecule. So it's in a gaseous state. Or it could be in liquid state, like water, right? And that's, so if you mix something and water is produced, right? It can be either in a liquid state, or if it was heated, then that water will be now vapors, which would be in a gas state of water vapor. So if it's a gas, then we put G, common G. If it's in a liquid state, then we put L, common L, in the bracket for the state symbol. So that's it for how to know what type of state each substance is when we're looking at primarily double displacement reactions. So now that we know the reactivity series or states of matter for the different chemicals, in our next session, we can look at starting to write chemical reactions, knowing what our reactants are and how they are mixed together to give us a product or products based on the type of reaction that will happen. So thanks for watching. Hope you understand a little bit more on types of reactions, reactivity series, as well as our solubility rule that we just did. And I'll see you next week. Bye-bye.